Alright, so we're going to graph this hyperbola, and so for that we want to figure out where the vertices are, where the co-vertices are, where the foci are, and we want to start with where the center is at. So what I like to do is just list out like what the H, K, A, B, C are, and this will help us, get organized. So the H, remember it's x minus h, so h is 1, and then it's y minus k, and so k is -2. And so then that tells us that the center will be at 1, -2. So we can start there. So 1, -2, our first point. Now, this is going to be a vertical hyperbola because it's the y group comes first. It's y minus x, so it's going to be vertical. It's going to open up and downward. And then a will be the square root of 9, because 9 is a squared, so a is 3. B will be the square root of 4, because it's just 4 is b squared, so b will be 2. And then find c. We're going to use the equation c squared equals b squared plus a squared. So c squared equals 4 plus 9. And c will be the square root of 13. And that'll be about 3.61. Okay, so for that, I like to plot the vertices first. So the vertices are going to be 3 units up and below the center, because it's a vertical. Since it's a vertical hyperbola, it's going to open upward and downward. So the vertices are going to be on the vertical axis. So then we start at the center here. We're going to go up 3, 1, 2, 3. And that'll be one of our vertices at 1, 1. And the other one will be 3 below. 1, 2, 3. So at 1, -5. Then we find the co-vertices. We using B. We go 2 units to the right and left of the center. So 1, 2 will put us over here at 3, -2. And then 2 to the left, 1, 2, -1, -2. The co-vertices. Three, -2. Now we find the foci. The foci are going to be 3.61 units up and below the center, because the foci, remember, are going to be on the same axis as the vertices. So we're going to do like an estimation. So 3.6, so above here, so like it'll be like maybe around right there. Put an F1 or F1 for that. And the other one, 3.61, so like below, so right below the other vertex. So the foci will be at 1, 2.6, or 1, 1.61. And the other one will be a 1, -5.61. And then what I recommend is now draw a rectangle through the vertices and co-vertices. This will help you draw out the branches of your hyperbola and help you also determine the equations of the asymptotes. So like this. And the asymptotes, remember, are lines that go through the center and to the corners of this. So we go through here, up 3 to the right 2, up 3 to the right 2, up 3 to the right 2, so like that. That'll be one of, we'll call that one y1, that'll be one of our asymptotes. And the other one going the other way, down 3 to the right 2. Down 3 to the right 2, 3 to the left 2. Call that y2. And so to find the equations of the asymptotes, I recommend just using slope and intercept form. So just, let's write the asymptotes. y1 will have slope of 3 over 2, 3 over 2x, and it would cross halfway between -3 and -4, so minus 3.5 for the y-intercept. And then y2 would be the opposite slope, so -3 over 2x, so that direction. And it will cross halfway between -1 and 0, so it'll be minus 0.5 for the y-intercept. Alright, so now we just draw a hyperbola as best we could. Remember, these are asymptotes, so it's going to be, they're supposed to be approaching it, so this up, there we go. Other side like that. Alright, pretty cool. And there you go.